Hi, let's learn factors. So factor is a number which divide another number without any remainder. So let's understand with the help of one example. So 10. Let's find out the factor of 10. So definitely 1 is a factor of 10. So if we divide 10 by 1, we'll get no remainder. Then 2 is one of the factor of 10. If we divide 10 by 2, we'll get no remainder. Then next is 3 is not a factor because we'll get one remainder if we divide 10 by 3. 4 again is not a remainder. We'll get 4 is not a factor because we'll get 2 as a remainder. 4 multiplied by 2 is 8 and then 2 will be remainder. Then 5 is a factor of 10 because we'll not get any remainder, and then after 5 we don't have 6, 7, 8 or 9 as a factor of 10 because if we divide 10 by those numbers we'll get remainder. And then the 10 is the factor of 10 because we'll get no remainder. So let's now see like what are the factor of 15. So 1 is a factor of 15. If we divide 15 by 1, we'll get no remainder. Then 2 is not a factor, so we cannot write 2 as a factor of 15. Then 3 is a factor of 15, we'll get no remainder. Then next 4 is not a factor of 15. 5 is a factor of 15. 6 is not a factor of 15. 7 is not a factor of 15. Then we don't have any number in between 5 and 15 which is a factor of 15, and then the 15 is the factor of 15. Will not get any remainder. Similarly, the factor of 20 are 1, 2, 4, 5, 10 and 20. So let's understand what we derived from these examples. So 1 is factor of every numbers. So yes, 1 is a factor of every number and the smallest factor of every number is 1. Then 10, 15, 20, which is the number. So every number is the factor of itself. So highest factor of any number is the number itself. Then every factor is less than or equal to the number. So here every factor of the number other than the number itself is less than and then the number itself. So the factor is either equal to the number 10 in case of a 10 or less than the number 1, 2, 5 is less than 10. And fourth, number of factors of a number are finite. So they are limited number of factors. There are not unlimited or infinite number of factors. So for example, 1, 2, 3, 4. Number of factor of 10 are 4. Number of factor of 15 is also 4. And number of factors of 20 are 1, 2, 3, 4, 5, 6, 6. So similarly, there are limited number or finite number of factors of any number. So prime factors. So prime factors is a number which is a factor of a given number but also a prime number. So as we know, let's find out the prime factor of 10. So we know 1 is not a prime number because it's divisible by only one number. So prime number is a number which is divisible by only two number, which is the number itself and 1. So 1 is, we know, is not a prime number. The smallest and only even prime number is 2. So here the prime factor of 10 is 2, and then next is 5. Yes, 5 is also a prime number. 10 is not a prime number. 10 is a composite number. So prime factor of 10 is 2 multiplied by 5, 10. For 15, 1 is again not a prime number. 3 is prime number, 5 is prime number, and 15 is not prime number because the factor of 15 are 1, 3, 5 and 15. 4 factor of 15. So 15 is not a prime number. So prime factor of 15 is 3 multiplied by 5. Similarly, we can do it for 20 and other numbers. So let's try to learn how to get the prime factor using factor tree or the table method. So let's try to find out the prime factor of 36. So we can write 36, we know 2 is a prime number. So we can write 36 as a multiple of 2 multiplied by 18. So 1 is a factor of 2 and 1 is the factor is 18. Let's further divide 18 by 2. So 2 is again a factor which is a prime number, and 9. The 9 have 3 as a factor which is a prime number. So 3 multiplied by 3 will be 9. So let's understand once again. So 13 we can write 2 multiplied by 18. 2 is a prime number, 18 is a compound number. So 18 is a composite number, so we cannot we can further divide this 18 into 2 multiplied by 9. So here 2 is a prime number and 9 is a composite number. 9 we can further divide into 3 into 3, so which is both of them are prime numbers. So we can write the prime factor of 36 like 2 multiplied by 2 multiplied by 3 multiplied by 3, and if we do the product of all these factors, we'll get the number 36. So 2 multiplied by 2 is 4, multiplied by 4 multiplied by 3 is 12, and 12 multiplied by 3 is 36. So we can do this by table, like we write 36, we divide first 36 first by 2, then we'll get 18, then again 18 we divide by 2, we'll get 9. We get divide 9, we divide 9 by 3, we'll get 3, and then we divide 3 by 3, we'll get 1. So 2 multiplied by 2 multiplied by 3 multiplied by 3 are the prime factor. So table and factor tree give the same answers because we have only a unique prime factor of a given number. Let's do one more example. So find the prime factorization of 980. So we can first try out with a table method. So 980 we divide it by 2, we get 490 if we divide 980. So 2 4 is 8, then we get 1 as a remainder, then 18, 2 9 18, and then we get 0, and we can write out 0. So 490 if we divide by 2, we get 245. Then 245 will not be divisible by 2. It will also not be divisible by 3. Then let's try 5, because after 3 the next prime number is 5. So if we divide 245 by 5, we'll get 49. Then 49 we can 49 we cannot divide by 5. Then let's try next prime number 7. So if we divide 49 by 7, we'll get 7, and then again 7 we can divide by 7. So remainder is nothing. So we say 2 multiplied by 2 multiplied by 5 multiplied by 7 multiplied by 7 is 980. So if we get the product of these factors, which are the prime numbers, we'll get 980 as a product. And these all numbers are prime numbers, and they are called the prime factorization of a given number, or here in this case 980. We can also do this prime factorization by factor tree. So let's try to do it, how to do it, but I'll recommend table method because there are less chances of making mistake here. So 980 we can divide 2 multiply by 490. 490 can be divided into 2 multiply by 245. 245 can be further divided 5 multiplied by 49, and then 49 can be factorized into 7 multiplied by 7. So 2 multiplied by 2 multiplied by 5 multiplied by 7 multiplied by 7 will be the prime factors of 980, and if we do the product of these factors, we'll get 980.